Alright. I'm unmuted now, so. I'm sorry.
You can start whenever you want. So.
Oops.
Or do you want me to introduce?
You can introduce. I don't know.
There's also a mic for down that side.
Yeah.
You
I,
want?
I,
I don't
I don't know. I think the room's pretty small.
Yeah, there's just one.
Yeah.
Writer.
How are you? Alright. Hey everyone, thanks for coming, guys. We're members of HackMIT. This is like our first workshop for Hackweek, where we're going to be having multiple events this week, hosted by sponsors and other groups. Here's two of our members, Evan and Adam. They'll introduce themselves in a second from our dev team, and they're going to give you guys a quick workshop on intro to hacking. Yeah, I hope you guys enjoy it. And also about the bubble, we'll hang up over in like 15 minutes in a quick break. Thanks.
Yeah, hi. I'm Evan. This is Adam. We both helped with dev. So if you use like Plume to register for Hack, we helped make that. And yeah, I guess today's just meant to be like a pretty chill workshop just to get familiar with some of the tools you might use during the weekend. I guess just I don't know, just show of hands, how many of you guys have like written like HTML, CSS before? Okay. It's like half. Um, so HTML CSS is just like the bare bones, the most bare bones way to make a website, at least on the front end. So like when you interact with the website, you're interacting with the HTML and the CSS, and that's what determines what gets displayed to you, um, and also there's also JavaScript, which determines how you interact with it, but we don't really talk about that too much. Yeah, so HTML is sort of like the skeleton of your page, of your website. So is the skeleton of your website. It determines how things are structured, but it doesn't determine how things are styled, and that's CSS. So for example, and the way it does this is through nested boxes. If we open up like a MIT Dining, for example, and we just like look at the source code, you'll see there's like nested boxes everywhere. So for example, if we focus on like this nutrition box, so there's first this outermost box, which is just like the box that determines the page. And then if we click in more, then um, we have this container which determines the nutrition box, and then nested inside of that are further smaller subdivisions. And if you finally get down here is where there's like text for what you want to put there. And then like below that is like the link, and it's all structured sort of in order of your website. And yeah, this nested box structure helps you organize things. Uh, yeah. So yeah, as another example on the XKCD website, all these things are nested boxes, and that's written through HTML. Yeah, so now I'll just go through like a basic structure of what an HTML document might look like. And you can actually see this if we go back to the this website here. It has a lot more stuff than just the bare bones that I'm showing, but we have the doc type HTML declaration at the top. We have a body and head. So head contains a lot of like metadata. It links things like your CSS style sheets, things like that. And then your body actually contains your contents. And um, yeah, in this case, we can go through the nested structure again. So because we have a nested structure, every single HTML element has opening tags and closing tags, and nested content inside of them. So in the case of our website, we have head, which nests inside a title, and that's I said head is where the metadata is contained. And in this case, it contains the metadata for the title of your website, which you see at the top. And in other cases, you can also put your favicon and things like that. And in this nested box, we have the body, which is your actual website, and then nested inside of it is both a heading and a paragraph. Heading denoted by H1 and paragraph denoted by P. So there's a lot of details here with all of these HTML tags that I've been showing you and all these boxes, but the good thing is you probably don't really need to actually remember these too well. A lot of them are very self-explanatory, like heading, body, and the headings and paragraph, or division, which is yeah, just stands for division and lays out divisions of your website. Um, you don't really need to memorize these that much these days. Like you can Google them, and of course you can also use AI, and it's very, very good at like menial things like getting your HTML tags and things like that. Um, and I guess some other things that you might want to know about HTML is um, there's you can sometimes put stuff in the opening tag with attributes. We'll see more things like this when we talk about React as well, where we pass things down into things that are like HTML elements. Yeah. Another kind of HTML, uh, or another pretty common HTML tag is links, and it'll use the attribute that I just talked about by putting href at the top. Um, yeah. And same goes for things like images. Okay, this is like not that important, but this is just like how you put your path to images. So if you have um, an image and you want to link the source, so these will store inside some other folder within your website. Um, so this is all sort of abstract because we don't actually have any code in front of us, but like if you have a file structure like this, you have to always make sure to actually put in the path to your actual image. But all sorts of bugs like these you'll probably just end up seeing when you get to making your websites. Um, so yeah, we'll pause here. Are there any questions just about like what HTML is? I'm sure you've all interacted with it in some form or another uh, in your life. All right, great. Um, some other HTML, the some other nested boxes that we can see are the division tag. And the division tag just lets you lay things out and divide them. This isn't like in this case, it actually changes the website. It doesn't change the website at all. But you might use these if you want to style them and like add spacing or padding or things like that around the elements in your website. So yeah, again, there's like a bunch of these tags, and you really don't need to memorize any of them, or but you should just have a general understanding for how things are. And especially these days, if you're doing front end, a lot of it can be like automated, but the most important thing is like you just have to know what's going on, right? Otherwise, like you can have a whole jumble of code for your front end, and you might lose what's going on. But you should just have a general idea of like the things are nested boxes, and uh like you have attributes and um yeah, basically like those are the main ideas. So that's a quick rundown of HTML. I guess I'm throwing a lot at you guys if you haven't ever seen HTML, but we'll go through this and then we'll talk about CSS for a bit, which is actually how you style your websites, and then after that we'll talk about React, which is what you'll probably actually use if you're going to be building a web app. Um, Because these days, working in bare bones HTML CSS is very clunky, and we have frameworks like React that make it a lot easier for us to do things. But you still have to understand HTML and CSS to use React. So, yeah, so CSS is how you style these nested boxes, cascading style sheets, and it's just a set of rules for how you style things. You specify things like your font, how much spacing you have, colors, etc. And yeah, so here's just an example of the MIT Downing website with and without the CSS. Um, you can actually do this just by going through here, and um, I think if you look through here, there's like a bunch of like style sheets you can see, like main style CSS. Um, and if you like delete these, um, if you delete these, like the style gets messed up. And so you need the two things to make your website work. Yeah. Um, so yeah, so CSS just works on top of HTML and um, has a bunch of rules and a bunch of like actually CSS can get really deep. There's like lots of tricks you can do to make your website look certain ways, and I don't really know like all of them either. But yeah, it's just a really useful tool to help make your website look like however you want it to. Yeah, so a pretty basic example of what CSS looks like is it usually looks like these open brackets with specifications for how you should style something. Actually, if we go back to the actual website, um, let's see. So, all right, this is a little bit obfuscated, but you can actually see the same structure here. So this is the CSS for the MIT Dining website, and um, okay. Um, It's not very, you can see one example right here is .wp block archives dropdown label, and it has the open bracket and closed bracket. And it has some sort of specification in there, which is the structure that we're seeing over here. So we have like some selector, which selects what part of your website you want to style with that CSS rule. And then we have the open brackets and a list of properties and values. In this case, there's just one property, which is display, and then a value, which is block that determines that you should set your WP block archives dropdown to display block mode. Um, yeah, that's the basic structure for CSS. Um, yeah, so if you like styling things, if you like designing things, you'll probably find yourself in CSS files and messing around with things to make them look nice. So yeah, that's a selector, the property, and the value, which determines what value the property should take on. So as an example, if we have our hello.html from earlier, which is really bare bones, we have the heading, paragraph, and info. Um, then in our style CSS, we add the following attributes, then it'll change to look something like this. Um, yeah, and I guess you guys already saw an example of that if we remove of going the other direction, if we remove the CSS, it goes back to like the Times New Roman default settings. So another way you can actually do styling is through attributes. So, or specifically the class attribute, which lets you style things on your own. So for example, so in this past example where you're selecting div, you can only style all divs with the style that you're writing. But in this case, you can use classes to determine how you're styling things. So classes are you name a class like this. And in the previous, in here also, .wp block archives dropdown is an example of another class that the MIT Dining website uses. Um, but now you can use classes to have more granular control over where you style things. So instead of in the previous case where we have all all divs being styled by this red Arial font 24, you see both paragraph and info get styled as red, which might be unintended. If we use the info class, then we can choose to only style the ones that we place the info class onto. And yeah, that's something that you might do yourself. Or there's also CSS packages that sometimes have pre-built classes, which you'll add on to your HTML elements. An example of that is something called Tailwind CSS, which you might encounter. So yeah, just putting it all together. Um, Another way for you to instead of the way that you actually combine these in the total document is you link it in the header, which we already saw in the MIT Dining example. Um, and it's another example of metadata that you contain within your website. Um, so actually, we will not try it out, but we'll try it out in conjunction with React, because React is built on top of HTML. So when you're writing React, you'll be writing HTML yourself. Yeah, so the last few things that you might want to know about CSS is this thing called Flex. Um, so actually, if we go back to the MIT Dining website again, um, so let's see, in like okay, this section it's like there's a bunch of like sheets of text. They're laid out like both like vertically and horizontally. Um, and then if we go back to the header and we the um delete the style sheets. So um so if we delete the style sheets, we see like the order of these things, which used to so dining location. Or anyways, there used to be like ordering to these things. Some of them are horizontal, some of them are vertical, but all of that gets deleted once you delete these style sheets. And Oh yeah. Once you delete them, it loses all order and everything gets laid out vertically. So the way that things are or the way that things are aligned and ordered within websites is through something called Flex. So Flex is just a yeah, the new way. I don't know, this float thing is very old, so nobody actually talks about it even. But Flex is a way that you can order things on your website. Um, and Flex gets very deep. There's a lot of specifications, but in essence, it lets you specify um, which way you write things. So I think the best website for this is this one here. It sort of lays out how Flex works. Um, for example, I was just saying like everything defaults to listing and vertical on the website, but there's something called flex direction, which if you apply to your CSS selector, then you can determine whether it goes as a row or a column, or even row reverse, which means the things that are ordered like top down within your nested box would instead go right to left instead of left to right. But this website is pretty helpful if you're really trying to get in the nitty-gritties of aligning things on your website. Um, yeah, and we'll give you guys a chance to maybe play around with things like Flex or any other CSS later. Um, yeah, so I think that's all I'll share for um, just HTML, CSS for now. Are there any questions before we go over React and then oh yeah, go over React. Okay, then we can also take a break here and maybe you guys can get the boba that you're promised.
We just do like the kind of civil. It's like first row. Everyone in the first row can come up and grab the real quick. Whoa. They're all plastic grabs. Yeah. Individually. You can go ahead. Yeah, you guys can go ahead. You got one over. I'm gonna go second row or like next row. Oh, wait, I know. Like. Yeah, yeah. Wait, I think you can know it. Wow.
Hi, this is Taro. This is
Oh, I saw it. I need like jasmine and then.
I think this is mango
Yeah, mango jack.
mango green tea.
Oh, good shout, good shout.
Yeah.
Matcha.
Is it matcha?
Japanese green, yeah. Matcha.
Okay.
All right, yeah. If you haven't gotten boba yet, you guys can come on up.
Sure. Wait, right now. We have another. Japanese green.
Yeah, Japanese green matcha. Enough for everyone at one. Yeah. I think we got like 40.
This is not.
Yeah.
Yes.
Yeah, bro. I should go run out.
Back, bro. Most people dipped, bro. The room capacity is half.
They type it the shit. I learned about it recently.
5G is really good.
I was in bad shape in last team.
Yeah.
Dude.
Wait, you guys get any?
No.
Yeah,
Take it. You don't want
Where's
it?
your matcha cup?
Wait, I haven't taken one.
I didn't,
All right. All right. Let's get back to it. Yeah.
I don't take
Wait, do
it.
you have matcha? Okay. Okay, sure.
Bro, I don't play.
Huh?
I don't, bro.
Adam, you want a matcha? Sure.
Damn, looks like Sandra's.
I don't want to get back to it then.
Okay, I guess 40 wasn't enough.
The perfect amount. 40 was like exactly enough. All right.
I think so.
We're gonna get back to it in like a minute, guys. Thanks.
Okay. So HTML CSS is probably like the sort of like lowest level you'll get to in terms of like web development or on the front end. So it's basically any frameworks that you'll probably end up writing stuff in get converted down into HTML and CSS, and of course that gets converted down more, and then or that data is actually what's sent around between servers and displays websites for you. But writing all that HTML and CSS can be pretty tedious. So as an example, let's look at this website of someone's Facebook. Okay, so in this person's Facebook, we have a lot of repetitive elements. For instance, we have all these images of friends. Each of these are essentially the same element, except their name is changed and then their image is changed. Another example of repetition here is each of the posts are essentially the same, and each of the comments within each post are essentially the same. But if you were to try to like display all this with bare HTML and CSS, you would have to like copy paste the same chunk of HTML over and over. So essentially React, yeah. So it would look something like this, where we have a bunch of things like that look repetitive. So the way that we fix this is through a framework called React. So React was something developed over at Facebook to make their life easier, but it's an open source framework, and it essentially lets you create modules within your websites and make things modular, and so that you don't have to repeat things. And the whole idea behind this is that you're going to create these things called components, or which look like a fake HTML tag. So you can define essentially your own sort of like HTML tag. You can define it with custom properties. For example, in this example, we might want to create our own HTML tags called navbar, friends, and feed, where friends creates this element on the left here. Feed creates the element on the right. And then we can get okay, so this is not exactly sorry. But we can also repeat them. So if we wanted to instead like have two friends sections, we wanted to have a friend section instead of another feed section, we would be able to write friends, and then we would have two sections of friends. But essentially, yeah, you're able to create these functions or these modular components that represent sections of your website that can be repeated and take in inputs and things like that. Um, sorry. No, I don't think Mateo is here.
Yeah, until the. I think we're good.
Alright, you guys want to do the discussion outside if you want to continue?
Sorry.
All right, so yeah, back to these fake HTML tags. You can essentially define each of these to be these components, and you'll use a version of like HTML and CSS to define these fake HTML tags, and then you can use them over and over without copy pasting that code for your website. So yeah, as I said, these things are called components, and components can be whatever you want. And they create this abstraction that let you define HTML and CSS for that and repeat it. So yeah, I guess more of a breakdown for how a React app works. The root component, the entry point for your React app is going to be the app component. And this is just by default in all of your React apps. And then you define things within your app components. And that's how you build your website. So in our case, we would define things like the nav bar, the info bar, and the feed. And then within the feed, we could have a bunch of post components. And this is where that modularity comes into play. And then within each post, we can have further components. And in the end, it's sort of like this tree structure where we have dependencies going down. So the app component depends on things below, and it continues. I guess it doesn't have to be. There's another thing is, for example, or never mind. But yeah, each you can go deeper and deeper into each component, and it can depend on more components. And then finally, you'll probably have some components at the root, or at the nodes of the tree, which are just defined in terms of HTML, CSS, and JavaScript. Yeah. So any questions on the basic idea of React and like its motivations? Yeah,
Stuff like define components.
right.
Is it only like one that you define, or are there ways to like share components?
Right. So there's a lot of like pre-built React components that exist, like from like React component libraries. An example of one is like I think so Chakra UI, for example, gives you a lot of pre-built components. But oftentimes, actually, I don't know how often people actually use these component libraries. There's also like shads. So sometimes people copy paste components from other people. So the shad CNUI like has a bunch of components, and then um, you can copy and paste their pre-written code and use it. But anyways, yeah. So a lot of people have pre-built components that you can use these libraries, but a lot of the time you might also just be writing them from scratch. Yeah. Uh, yeah. Any other questions? All right. So I think if you guys have your computers, it would be nice to actually start maybe just trying to do some stuff and seeing what an app looks like with all the HTML, all the CSS, and all the JavaScript. So we're gonna use something called Vite. So there's a bunch of these like builders for React apps that just get you started and run the app for you. And yeah, so we're gonna use this command npm create. Oh, you also have to install Node if you don't have it.
Yeah, yeah, we're gonna like spend some time on this slide. So if you need any help setting things up, just let us know and we can walk around. If you need help with installation. or anything else?
Yeah. If you don't have Node, yeah, just like search it up and go through the installation instructions. But you'll probably want to have it because you'll probably be using it for any app you build. Yeah. So Node is like a piece of software. I guess it's not an app, so or it's not like an app like VS Code that you would open up. It's like a package that exists within your computer once you install it, and it also manages other packages for you. Um, or the npm that comes with it manages other packages.
Show an example.
Um, yeah, yeah, I guess I can show um show what this looks like once you get Node installed. Um, once you have npm, if you run this, then um, this just creates a folder called my React app, um, which my React app, which comes with all these pre-built folders. It has some like images already in there for you. It has some CSS, and oh yeah, sorry. And it has app.jsx, which, as we mentioned earlier, is like the root entry point for your React apps. Um, and this already has some React code in there. And as I said, React, basically you write HTML for React, so you can see like we have like all these HTML elements within the React component, which defines that React component. Um,
Slide.
yeah. Uh, oh, and also you want to npm install once you're in the folder. Uh, you want npm install once you're in the folder. And then you can run npm run dev. And that starts a React app, which hosts a website that you can see. So yeah, just the command for this is on the screen here. And yeah, just raise your hand if you have trouble installing Node or running Vite. Sure. I don't know. Yeah, yeah, you should be able to. Are you also colors? You can just try things in here. What is that?
I just typed it out. It's like and wait, it's like the little song. Last day. Yeah. I just really make those. Oh, yeah. I remember I'm looking into it. That's like a little more. Oh. It's not that big. Wait, so I was like, why did you do this?
Okay, I don't remember how I installed Node. But
That gives me anxiety. I'm like silly. Scared about my yeah, and it's like, you're already, like,
yeah.
You installed Node on Windows?
Huh?
Have you installed Node on Windows?
I don't know, just uh,
yeah, pretty bad.
Yeah. So I basically was it's a really bad thing. Well, like, what's good? I can't tell. Actually, yeah, that is bad. Oh, you do a hospital. Not a hospital, yeah.
I mean, it's like, wait, did you get this? Like running scripts.
Yeah.
Yeah. Wait, we'll figure it out.
I think very short. Is that what getting landed? I thought that's
Try it out. I feel like send it to somebody.
But it's yeah, where do you want? I think it's had a tree. Yeah, sounds like, whoa.
Interact with anyone with Windows.
Huh? No.
I have like 3 people with Windows who are can install on the correctly. The official one uses Docker. You can like, oh, chocolate sheet.
Oh yeah, yeah.
It is the thing below, like this Mac OS installer. Like I think,
Oh, well, you, oh,
yeah, like for
that doesn't
Windows.
work?
For Windows.
Didn't work.
I think not. It's bad. Not.
Wait, I think Choco's pretty good. I think I used that before in the past. But I don't know. We can start it, right?
Yeah. Do you have things to like go over?
I was just gonna do one thing, like make a Python component.
Okay.
All right. Um. All right. So I hope like um. All right. Can we come back? So I hope everyone has been able to install Node and get this app running. Hi. Yeah. So I hope everyone's been able to install Node and get this running. And I'll just like do a small edit to the app and hopefully you can follow along. So the way the structure works is this npm run dev creates this client server, which is constantly running. And as you make changes to your website, so for example, like it says, click on Vite and React logos. If we delete some stuff here on the HTML, then it'll be reflected here. Or maybe a more obvious case is yeah, if we add that here, it gets immediately reflected in your website, and your dev workflow is going to be you're going to have some sort of client server up, and then you're going to edit your files, and those changes will be reflected. So just one quick edit that I think I'll make to this file, and you can follow along, which sort of highlights the usefulness of React is we can make a component. So right now this like demo comes with this like little button here that increments as you click it. But one nice thing we could do is maybe we want to have multiple buttons and we want to use this button over and over. So we can try to make like a button component. So we can make a button.jsx component, and then right now the code for the button, the HTML for the button is here. And we want to sort of create a another React component to replace this whole section so that we can just write like our big button slash. So if you look at the structure of app, we can sort of replicate this to create the button. So app has this like function opener. It has this like little thing called use state. You don't have to worry about that too much. That's just a little hook that maintains the state of the button, like the counter on the button, and then we export it. So we can reflect the exact same structure in our button.jsx. Now we don't need these lines, but we can reflect this exact structure and export this button. So yeah, and for the actual button that we want to return, or so the way the structure of this is it's sort of like a function, and then I copied in the use state from the from app, but then we actually have to return something. So if we look at app here, it returns like this HTML, or we call this JSX, but essentially just returns the HTML, and that's what we want to do for the button. We want to return the HTML for the button. So in our case, we can copy paste this button from here, and we can return that. And so yeah, so actually in this case, this should be pretty much good. And then we can put button in here and import button from the component that we just made. And now let's say we get rid of this counter here because we maintain the counter within the button. This button is now a modular component that holds a counter and increments and can be imported. So actually I broke something, but yeah. So now we still have the same functionality with the button, except in terms of our code inside app.jsx, instead of having like the whole code for the button, we just have this one little button tag. And as we talked about before, this lets us have repeated examples of something, and now we have multiple buttons, yeah, that also maintain counters. Yeah, yeah. So you import button from /components /button, and then now you're able to access this. Yeah. So there's other things you can do. Is you can also pass in things called props, where like these are like JavaScript functions, and functions can take in inputs. So for example, you could uh, put in this put in like a component called children, and then now you can actually do something like this. And previously it said like count, but now we can like put in some amount of unspecified text, and this gets passed down into the button, which then renders the button conditionally based on what you put into the this custom component that you defined. Yeah. So yeah, that's like the main structure of React, and you'll just be doing that if you build bigger React apps. You'll just be doing that at a larger level. You'll create more components which depend on other components. It's pretty similar to any sort of like modular design when you're doing any sort of coding. Yeah, a little bit more. Sorry. Yeah. Yeah. And this, oh yeah, this use state hook, it's called a React hook, and it's just a way to maintain a state. I think it's pretty self-explanatory. You have a you have this like count here that saved, and you have a set count variable which can update the value of count. And that's just how the button maintains the state. Um, yeah, sure. Um, are there any questions about that like small exercise? We can wait a little bit so that you have a chance to play around with it.
Just go. Huh? Just go. Yes.
I don't think that changes the display, right?
I guess not. Yeah.
Make the color thing. That even get better.
Huh? All right, let's move on. So, um, yeah, now that we have some working front end code, which is kind of what the client sees, the user sees like all this React components and CSS and all, but it's still not enough to make a fully functioning website with a server or a backend. So I'll be talking about the necessary components to make a server, including HTTP requests, APIs, and the backend. So yeah, what actually happens when we visit a website? The computer and the internet can do two things when they interact with another computer. You can either send a request or receive a message. And um, this is like the divide that's very common in um, like designing these websites, where you have a client, which is the page that the user sees, and then a server, which is the program that's the company or the owner of the website runs behind the scenes. Both components need a program running. So say for Facebook, Facebook needs to have their servers, which kind of store the information and send information to the user. And then the user needs to have their own computer where they go on a browser and um, go to facebook.com. So yeah, this is what HTTP requests look like. The client sends this request that's like, hey, I want to see your page. And then ideally, the server responds and gives them uh, stuff to load. And once the server sends this response, which includes these HTML and React components back to the client can render it. And that's kind of what we've been doing so far, is rendering that code. So who sends the request? Uh, anyone wants to respond? Never mind. Yeah.
No, they have the fringes on.
Hmm? Oh, there, great. Yeah, so the client sends a request, the server sends a response. Yeah, so here's the model again we had, where the client says, hey, I want to see Facebook. The way that this is written in code is like this. This is an HTTP request. There's this method name at the top. It says get. that means that we're asking for something from Facebook. The other method name that is commonly used is called post, where we're kind of sending something over. The second line, that's the address we want to go. And then the third line is the protocol. HTTP 1.1 is the most common protocol. This is like kind of just the standard that everything on the internet runs over. And then the response that has some metadata like the date. It has this thing called a status code 200. And then it has the body, which is the response. So yeah, so after we've sent this request, we've given Facebook like our get request, and then we get this data. We're not done. We still need to talk to the server. Right? If we click a button and we want to like go to a new page or submit information, we need constant interaction with the server. So yeah, here's another example. If we're interacting with Bank of America's server, we need to send our authentication details, and then the server needs to do the 2 rounds. Like you need to authenticate, and then you need to send over the information. Or as another example, like transferring money. So yeah, there's many times we need to talk to a server. And let's go through this. Yeah, with the HTTP 1.1 protocol, this is pretty easy. So like here's an example of like the first request that you send over. This is the 6102 website, previously known as 6031. When you click on a link, your computer sends this request at the top here. And then the server sends this stuff back. Yeah, if you want to send another request, you're already loaded on this page. So clicking buttons on this server yeah, loads the next kind of request that you need to send. And yeah, for all subsequent requests, usually what you want to do, it's called a post request. So earlier I mentioned there's 2 main types of requests, get and post. Here, here's a post request. The main difference being we have a body now. This JSON body of the request kind of sends over the information that we need. And the response is pretty similar. So here again is the kind of structure of request and response. They all look like this. The method is get or post. The header is HTTP 1.1. And then body is the information that needs to be sent, and it's the form of JSON. So status codes. So as you saw in this earlier slide, this response contains this code 200 OK. And there are all sorts of these status codes that the server uses to signal whether there's an error or whether the response went through. So the kind of most infamous one is 404, which you might know as not found. This is what happens when you query an endpoint and it does not exist on the server. So for example, if you go to the wrong link on a website, then often you'll get a 404. A 400, that's kind of the default bad request. 500 is an internal server error. So these are all very common error codes. Everything that starts with 400 is kind of like, it's the user's fault. If it starts with 500, it's like, it's the server's fault. It's like maybe the server you're going to has messed up. And then 200, that is what you want to see. That is okay. There's like some less common ones like 300 and 100, but the main ones are 2, 4, and 5. Yeah. So yeah. So now let's say that you you haven't like you don't know the person who owns the server. You don't know like what format they want your request to be in. None of that. How do you how do you learn this information? Right. Um, so for example, like for the 6102 website, we have this request up here. We go to web.mit.edu/6102/reading1/question1. But if we kind of change the URL name, like if we go to reading1/first question and send a request, where the correct endpoint is called question1, we're going to get an error, like 400 bad request, or maybe 404 not found. So how do we get around this issue of like not knowing what the request is? The answer is APIs. APIs stand for Application Program Interfaces. And these are specifications for what endpoints exist on a server. This is what I just said. Yeah, so companies like Google, Amazon, Facebook, pretty much any company provides these APIs. If they allow people to like arbitrarily query their server, they need to provide an API so that the user knows where to go. So here are some cool examples. Open weather, that's like a very common thing used by weather services. Google Maps, OpenAI, and then even things like the dog API. Yeah, this term gets thrown around everywhere. Yeah, question?
That provide access to the entire app's code, or it is copying.
No, it doesn't. That's a good question. It does not provide access to the entire code. It only gives the list of endpoints that the user can query. So like in this example over here, if we query like 6102/reading1/first question, we get an error. But with an API, we can kind of get a list of all the addresses maybe that you can go to. So like the API would tell you, okay, reading1/question1 is the right URL, and it kind of simplifies and organizes everything like that. So yeah, APIs get thrown around a lot, this word. It kind of has come to mean anything where there's like a client and a server, any kind of interface where someone on the web is offering some service. So there's a lot of companies in the past 20 years that are their entire product is building an API. Yeah, another thing, many of these APIs require authentication or require an API key. For example, like the OpenAI API. If you interact with OpenAI through the browser, that's okay. If you interact with the OpenAI API, then you can kind of like customize your queries. Maybe you can serve a website, maybe make a GPT wrapper, which is a website that kind of sends your request through OpenAI. All of these, you can't just rely on the browser. You need to use the company's specified HTTP requests library. So in many of these cases, you need authentication and you need multiple rounds of like sending over keys and payments. That's just many layers on top of this building block. There's also some tools for developers. These days, like I don't think you really need to know about these for debugging APIs. It's kind of nice to use the library's basic commands. So don't worry about these two, but these are some tools for testing APIs. So yeah, as we went over, the client and server is also sometimes called front end and back end, because front end is the front-facing part of the website that the users interact with, and then back end, which is your server, which has like all of the the meat of the website, like the data and the computation That's kind of in the back. It's not user facing. And then they interact through the API. So yeah, let's code a very simple API. I'll try to work off the code that we already have. Yeah. Great. So earlier, hopefully most of you are able to get to this page. This is the front end of your website, npm run dev. And you go to this link. So let's code some probably the most basic example together. So let's open a new terminal here. And as you see on the left, I'm in this My React app folder. I'm going to cd ... which goes to the previous folder. And then I'm going to make a directory called server. So, so now if I go back. Wait, what? Go back. Do you have anything in the directory for?
No.
Okay.
Oh no, I do.
Okay. All right. Show you 1 second.
We just do cursor dot from here.
Hmm?
Just do cursor dot.
Oh,
Shouldn't no.
yeah. All right. So you saw I just created this server folder on the left. I'll try to zoom in a bit more. And then we had My React app, which is what we had from earlier. Another thing it can do is kind of, you can rename it client if you want, or you can keep it as My React app. That'll be the front end, server will be the back end. So yeah, and then you can reopen a VS Code window in this workspace just to make it easier. So now in server, let's create a app.py. Just like in My React app in source, we have this app.jsx. It's convention to have app.py be the starting point of the server. And I'm just going to code some stuff on here. Your F key is broken.
Oh yeah, yeah. Did you get it back in?
No. All right. Yeah. If you need help at any point, Evan can probably come around and help. But I'm in app.py and server here, and I'm going to use something called Flask. Flask is the simplest of Python library for writing servers in web dev. And yeah, we can add these lines at the top. Doing sonify will become useful later. Another thing is cores. And then let's import OS. So
For your event.
Hmm?
Your virtual item.
yeah. Yeah. How do you do that again?
Python. Python dash
Python dev. Oh. Yeah, here, yeah. Yeah. All right. So Flask, like Node, will need an installation, but it's much easier in Python. So I'm just going to create a virtual environment here with Python.
CD server.
Hmm?
CD server.
Sure. Here. Yeah, sorry, I'm not used to this laptop. So I'm going to create a virtual environment here called Venv. This is a common thing in Python. You can also use conda if you want to look into that. Is it 3?
Also use UV.
We use UV.
Huh?
Okay, Python 3, venv. And then I'm going to source it and then activate. That's right. Okay. And then I'm going to pip install. Oh, sorry. So I'll run through them again. So inside server, I'm just going to create a virtual environment where the Flask library is stored. So Python venv dash Python dash m venv dot m venv, and then this sources the venv, and yeah, do you need this one again?
So the purpose of the virtual environment is that you have a separate set of packages that are not your global Python environment.
Mhm.
And sourcing just makes it that you're using the Python that's installed inside of your virtual environment instead of your global Python.
Yeah. Now I can do pip install Flask cores. If you ever worked with Python projects, then you probably worked with pip. And select interpreter. All right. Yeah. So now I'm going to go through the kind of lines that you need to create an app. The first for Flask, we can this is the command for creating an app. I can just follow these ones. Cores is the policy for who can interact with your app. So I think the default is I'm not sure what the default is, but I'm going to add this line called resources equals r slash API slash star origins star. Do this. Yeah, so this creates an app that can interact with anyone. Origin star is it just means that anyone can query the server. And after you've set these two up, you can start creating API endpoints. So app.route slash, you can do maybe slash hello. I've used your computer.
It's on him. You have to um
All right.
it should be showing.
All right. Yeah, I'll just make a very simple one called hello. So let me go back. All right. So yeah, okay. This app.route here specifies what's the the address of the endpoints. I'm doing slash API slash hello, and then is the function that it's occurs when you go to here. And then if name equals main app.run, this allows us to start the server, Python server / app.py, Python 3.
Yeah, it's just resource.
What do you mean?
Resource.
Yeah, I am. Okay, so sometimes your port will be in use by another program, so you can just change the port name to like 5001 or something. And it should look something like this. This is serving Flask app. And then it says running on this address. So yeah, actually I don't need OS. Let me get rid of this. How do I into this side? Change that too.
Yeah. Just add this.
All right, next I'm going to go into vite.config.js. This is on the client side. And here we can just add server proxy. This allows the client side to be able to go to the server at localhost 5001, which is where we put our app. And now I think that's all we need to be able to like query the server from the client side. So
Change order.
oh yeah, change origin. Another line that I forgot to add is this. The API. I'm sure you did that.
I don't know.
I think this should be good. Yeah, okay. Let's see if this works. Yeah. So now on the app.jsx page, we can add some functionality for querying the server. So here, use effect, that's another React hook. And fetch is the way in JavaScript and React to query from this API. And yeah, so this loads data. So I'm gonna also add const data set data equals use state. And put it here. So now, yeah, I have this this state that I'm setting inside of /API/hello. Sorry, I'm going through a bit fast, but
I'm sending message.
Message. Set message. Oh shoot, I'm sending message. Message. All right. And let's see if this works. So in one terminal, I have this app.py running. I'll run it again, Python 3 server /app.py. In another terminal, we can go to my React app, or if you've renamed it, client. And here we can run what we were doing earlier, npm run dev. And then if we go to this link, let's see. Use state. We need to define use state for React. There. All right. So yeah, now here's our website again. And as you can see, like there's this line here, hello world. And it's nowhere. Oh, just where's my VS Code? Yeah, so nowhere on the page did I actually write hello world. It's like it's just this here like message. And this is entirely set using the API here, using use effect fetch API slash hello. These conditions. You can also remove this one. So yeah, it's all coming from the server. So this is kind of the basis of how the server communicates with the clients and sends over this message. So here completely on the server side, like if I add some exclamation points here and then reload, might need to restart the server. Yeah, you can see like they show up here. So this is like the most basic type of API and querying the API. And kind of everything is built on top of this. So you can pretty much put arbitrary functions inside of here. Um, and then you can have more than just slash hello. Um, but yeah, hopefully that's somewhat helpful for understanding how the servers and clients work. So I think there's a few more slides here. Let me see. First, I think that was like a lot of coding, but are there any like questions anyone has? All right. So yeah, I think there's a few more slides here I'll go through. So um, here's like kind of more information on what's going on inside of the computer. So we have these two ports here, the front end port and then the servers port. And um, this is like the structure of a URL. If we go back here, um, you can see that the server is running on this port here, 127.0.0.1, also known as localhost. This is like um, this is you, like your computer. And then on my NPM, on my client side, it's also running on a port, and this is a different port. It's 5174. So when we go to the website here, this is the front end is on 5174, and then the back end is on the other one. And if we go to the back end here, like we're going to get some error. But if we go to /API/hello, you can actually directly query this from your computer. And it's just not, it just gives you the JSON here. Um, but yeah, that's processes and ports. So yeah, here's what I just said. Localhost is the same as 127.0.0.1. Everything is completely local. It's another matter to be able to display your server and your website to the cloud. But for now, we've set it up in a development environment where both the program running the client and the program running the server on your computer. But on more complex websites, or pretty much every website, are going to be split. It's just for development, you usually have them together. Yeah, all right. So any more questions about HTTP requests, APIs? Do I say code? Sure. On the right. Yeah, here. You're looking for this, right? Mhm.
Yeah. Are there any other questions as we wrap up the intro to hacking workshop?
Yeah. Actually, it's not necessary. So virtual environments are helpful in Python for managing dependencies. So if you have different projects, then you want to only install the dependencies you need for your specific project. So that's why we have it here. It's also possible to like install everything in your your base environments. But this is just easier.
Oftentimes there's also like certain packages will depend on another package having like less than or equal to some version or greater than or equal to some version.
Mhm.
And there's a lot of like conflicts with dependency trees that can occur.
Yeah, like here, if you go to like maybe pip freeze, no pip pip3 freeze. You can see the list of all of the dependencies, or let's put it into a file like requirements.txt. This is a very common pattern. I should have put it into server, so I'm going to move it. So here, requirements.txt is like the list of every Python dependency that is actually required to run these things. And a lot of these are just defaults. But you can see it's a lot of stuff. And this is like a very simple program where we just imported these two.
This is my global
Oh, is this?
list, I think. But yeah.
Well, even if there was none of Evan's global environments stuff in here, it would be a very large list. I think like the default has quite a few things.
Yeah.
So yeah, it's very nice to use.
Hi, John. This question, you don't run like environment, you
Mhm.
can break your system so easily because your operating system is using some dependencies of Python, and if you install another version or install a program that has conflict with other, you can one day log in your computer and you don't log because it's break. So it's very recommended to have like a virtual environment.
Yeah, I think that's less of an issue for Python than some other languages, like C, but or whatever your OS runs on. But
Yeah.
yeah, there's sometimes when that happens. Yeah. Great. Great.
Yeah. There are no other questions. Yeah, thank you for coming to Intro to Hacking. I don't know, there's some other events. Vinny, do you want to talk about
Yeah, sure.
some stuff?
Thank you guys for staying to the end of the workshop. So let's wrap it up for Evan and Adam real quick. Yeah, we have a few more workshops on tomorrow, but on Thursday we have like a slew of them. And yeah, we're gonna also be having a few more workshops on Friday. And if you guys are still like wanting to join HackMIT and compete, but you aren't attending already, we're also offering like free admission to the hackathon if you're willing to host someone. And we sent out the dorms to have that up with that also. But yeah, if you guys have any questions, feel free to stick around for like a few minutes. We'll be here. But thank you guys for coming. Thanks.